I've got some of the jeweler's scrap here. He needs a quick buck. He asked me to refine this for him. So we're going to do a quick refining on it and try to turn it around and get it back to him today. If you notice, there's some glue on here. He spilled some super glue in his collection of gold. I'm just going to call this 12K gold. And what we'll do is add some sterling silver to his gold to quart it. 66.3 grams. Alloying the gold with additional silver will reduce the gold content down to about 25%. Then we can use hot nitric acid to pull the silver back out, along with all the other silver and base metals that was already in the carat scrap. Next, I use a graphite rod to stir the molten metal to ensure a good alloy. The molten metal is poured into a metal container of water. You'll notice here I get a little bit of a steam explosion as I pour it in. I've had this happen before, so I just push on and continue with the operation. I cover the metal with some distilled water. Got to use distilled water here because tap water has chlorine. It'll form chlorides in there. Don't want that to happen. And then I add an equal portion of concentrated nitric acid. Cover it up, put it up on the heat so the nitric can start pulling the silver out of that gold. Adding silver and then pulling it right back out with nitric seems counterintuitive, but the nitric won't dissolve the gold. It'll get left behind. In quotation, one of the most valuable refining techniques that I've ever learned. This is my silver jar. It's full of scrap pieces of sterling silver. The blue liquid in the beaker with the gold in it will contain lots of silver, but it will also have a little bit of free nitric acid left in it. So I pour it into my silver jar that contains the scrap sterling silver to conserve the silver so I can recover it later, and also to use up any additional free nitric acid that's in that blue liquid. I add more distilled water and an equal dose of concentrated nitric acid to remove more of the silver and base metals from the unquarted gold in that beaker. I keep track of each nitric acid treatment by putting tick marks on the beaker with a marker. Here I'm incinerating some scrap sterling silver to burn off oil and grease, to add to my silver jar so I can continue to consume any excess nitric that's in that liquid. Our fourth nitric acid boil is complete. You can tell when it's done because there'll be no more fumes in the beaker. I pour this acid off into a container and save it for future use. Here's a look at the gold now that most of the silver and base metals have been removed with those nitric acid treatments. Here I'm adding more nitric acid to do our fifth and final nitric acid boil. Lack of fumes in the beaker and nearly colorless solution tells me that this fifth nitric boil is complete. I'll save that acid for some future use. I rinse the gold with some distilled water to get as much of the nitric acid rinsed off as I can, and then I add the rinse water to my silver jar. Here's a look at the gold now that all the silver and all the base metals have been removed with the nitric. The gold right there is very close to 3/9 fine, just like it is. But to make sure, what we're going to do is go ahead and refine it with aqua regia. So I'm going to add about 150 milliliters of hydrochloric acid. Here I add a little sulfuric acid to precipitate out any lead that may be present as lead sulfate. Here I'm adding nitric acid to form aqua regia in the beaker, but I'm not pre-mixing the aqua regia 3-to-1 or 4-to-1 like everybody says. Instead, I'm going to use small incremental doses to just dissolve the gold in the beaker. This is one of the most valuable refining techniques that I've ever learned, incremental nitric dosing. Cover it up and put it up on the heat. Using incremental nitric dosing to add just enough nitric to just dissolve the gold will ensure that I won't have a whole bunch of excess nitric acid in with my gold solution once this reaction is complete. Premixing the aqua regia 3-to-1 or 4-to-1 guarantees there'll be problems with excess nitric when we go to precipitate. There should be just over a troy ounce of pure gold here, and most of it has dissolved in 150 milliliters of hydrochloric acid and 15 milliliters of nitric acid. There's just a few crumbs left, so I'm adding just a few drops of nitric acid to get the rest of that gold to go into solution. Here I'm adding a few more drops of nitric. You'll see that the fumes go away and the particles quit dancing, and we just got a boiling solution now. That tells me everything has dissolved. Here I'm adding some ice cubes to the gold to cool it down before I filter. The ice cubes are made out of tap water, not enough contamination to report in a precious metals assay. We've got the solution cooled down. Notice the cloudiness. That's probably some silver chloride, but it may be some lead sulfate from the sulfuric acid that we added. I'm going to try to filter it out now. Here I've got a second clean filter flask. What I'm going to do is transfer that funnel onto the clean flask, and we're going to pour the solution back through the same filter paper a second time. It looks better, but we're going to try to get some more of that cloudiness out by pouring it back through the same filter a second time. Notice how clear that solution is now that I've passed it through the filter a second time. And what I'll do here is I'll transfer the gold bearing solution into that rinsed out clean beaker and get it ready for precipitation. And now for the best part of the entire video. I'm going to use some stump out, which is sodium metabisulfite, to reconstitute the pure gold powder back out of that solution. The sodium metabisulfite causes a reaction and causes the gold that has been dissolved in that solution to come out of that solution as metallic gold powder. It's a brown powder that settles to the bottom of that beaker. This is about 30 minutes time-lapsed, and notice how quickly and cleanly the pure gold powder settles to the bottom of that beaker. I pour off the waste in a separate container and save it because it may contain traces of precious metals. Here's a look at the pure gold mud in the beaker. Now I'll do 4 or 5 quick rinses with hydrochloric acid to get the chemicals rinsed off of our pure gold powder, and I'll save those rinses in my temporary container. I rinsed the gold with distilled water to try to get most of the acid rinsed off, and I'll add those rinses to my temporary container as well. Transfer the gold mud into a fused silica melt dish and put it over on my melt table so we can begin the melt. This is time-lapse condensed into a few seconds. I'm using 2 MAP gas torches, one to melt the gold and the other to preheat the mold. I finished the melt with my oxyacetylene torch turned way down low. Alright, here's a look at the pure gold bar. It looks really good for just a single refining. I normally refine it twice minimum to get high purity, but what I'm after here is a yield so that I can calculate how much I need to pay the jeweler for his gold. Here it is, our nice little pure gold bar. It's not ultra high purity. There's a little bit of frost in that one little cavity there. And I only refined it a single time, but this is very close to 3/9 fine pure gold. That's 32.8 grams. And I'm going to owe the jeweler $1,770. All right, this will conclude the video. Thank you for watching.